my sender or my IoT devices, and this is my receiver. Now, when the sender is sending the data, they are going to send the data in the form of a digital bits. Yes or no? Apart from digital bits,
Yes,
is
sir.
the way
Yes,
to send
sir.
the data. Now, those digital bits, basically, we send it through a digital signal. Okay. Now, I will send the data through my Ethernet medium, right? Or through medium. Now, this medium may carry digital signal or may carry analog signal. This may carry digital signal or may carry analog signal. Now, if it carries digital signal, there is no issue. Whatever digital signal I have generated at the receiver side, that same digital signal will come out and I will receive the data. But instead of the digital signal, if the medium can carry analog signal, the problem arises. Means that I have the digital signal, but my carrier or my medium can carry only analog signal. That case, what I have to do? I have to convert this digital signal to analog signal. Now, this is the situation when I have generated digital signal, but I need to send the digital signal in the analog form through the medium. That case, I need the digital to analog conversion. Now, for this digital to analog conversion, I require the shift keying concept. समझ में आया? Digital to analog.
Yes, sir.
मुझे ये shift keying चाहिए.
Yes, sir.
Now, there are three kinds of shift keying. Why three kinds? Because as already I told, to analog signal, this is my analog signal, is basically a sinusoidal wave. Analog signal will pass their data or the any kind of analog signal. It's an electrical signal or whatever signal is there. If it is an analog signal, that case it will go in a sinusoidal manner. Now, what does it mean by this graph? This graph means that this is the voltage, change of voltage. This one is the change of voltage. Means that if it is 0 voltage, maximum voltage is plus 5 voltage and minimum voltage is minus 5 voltage. Then with respect to the time period, if this is the time period with a fixed time period t, first half of the time period, it will move like from 0 voltage to, it will increase to 5 voltage, then 5 voltage to, it will go to decrease to 0 voltage, then 0 to, it will go around minus 5 to again 0 voltage. So when it completes one cycle, it becomes a single wave. Now this single wave goes in t second. T second maybe 0.005 second. Got my point? This is my time period. So एक time period में एक signal जा रहा है. Now whenever it is changing its voltage, actually it is called its amplitude. This voltage change is called its amplitude. So this analog signal will be referred by its amplitude. Apart from amplitude, what it refers? It refers also its angle, phase angle. Means that with the time, it is changing its phase angle also. Phase angle means right now it is in 0 degree. How to determine the angle at any instant of time? Means that at this instant, whenever it is started, this is also time period, same time period. Now at any moment of time, if I draw a tangent, now with that tangent, how much degree it has created, that is called its phase angle with respect to your plane. Plane के साथ मेरा कितना angle तैयार किया, that is called its phase angle. Now you can see that at any moment the phase angle is changing actually. At this moment, whenever it is coming to this point, with respect to my plane, the phase angle is 90 degree. Now here it is 0 degree. Now with respect to the time, my voltage or amplitude is changing. At the same time, it is changing its phase angle also. Phase angle is changing from 0 degree to 90 degree here. Now from 90 degree, again it is coming to 0 degree. This is again 0 degree. Now, if I say this one is 0 to 90 degree, again, sorry, it is not 0 degree, I'm sorry. It is 90 degree, 90 degree to, it is again coming to 180 degree. And from 180 degree, it is again increasing. It is coming around 270 degree. And when it comes over here, that is 360 degree. Means that when a single wave completes its traversal, it completes 360 degree. Means that if I consider it like this, from here it is starting and then it's completing its entire phase. From 0 degree, then it is 90 degree, then it is 180 degree, then it is 360 degree. So we can determine features of a signal at any instant of time through its amplitude, through its phase angle also, through its phase angle. समझ में आया? Or shall I repeat the phase angle once again?
Yes, sir. Phase angle, please once.
Okay.
और एक बार समझ
ठीक है. तो देखो एक मिनट. फेज एंगल में हम लोग क्या करते हैं? कोई भी साइनसॉइडल वेव हो, if this is the wave, the change of the shape of the wave determined by its phase angle. How to determine the phase angle? At any moment, suppose at this moment, if somebody asks that what should be its phase angle, that case I have to draw a tangent along this one. एक tangent draw करो, tangent और ये tangent तुम्हारा plane के साथ कितना angle कर रहा है, that would be its phase angle. At this moment, if I draw a angle and if it how much angle it is creating with respect to its plane, so that will be determined by its phase angle. So basically, whenever it traverses, this one should be your 0 degree, this one should be your 90 degree, this one should be your 180 degree. 180 degree means what? Out of phase. 0 degree out of phase. Okay, this one should be 270 degree, means 180 plus 90. This one is 0 plus 90 degree. And this one is 90 plus 90, that is 180 degree. And again 180 plus 90, that is 270 degree. Here also again 270 plus 90, that is 360 degree. That means within 360 degree, I am completing a total signal. Or through when the signal is traversing, its phase angle also changing from 0 to 90 degree, 90 degree to 180 degree, 180 degree to 270 degree, 270 degree to 360 degree. मान लो इस जगह पे अगर हम लोग ड्रॉ करेंगे कोई भी tangent, if I want to know what should be the phase angle, then its phase angle should be in between 270 to 360 degree. Yes or no? इस जगह पे
Yes, sir.
और
Yes,
इस
sir.
जगह पे अगर करेंगे तो 180 और 270 के बीच में, that means the phase angle might be in between 180 to 270 degree. इतना ही तुम याद रखो. At any moment, if I want to determine the phase angle, that can be determined by drawing a tangent along your plane. Clear?
Yes, sir.
Now,
Yes, sir.
so my signal is being featured. One is my amplitude, correct?
Yes, sir.
Amplitude समझ में है? What is amplitude? Your voltage level change. At this moment, what is its amplitude? At this moment, what is its amplitude means? What should be its voltage level from 0 to 5 degree? 0 to 5 voltage or 0 to minus 5 voltage. So एक तो हो गया amplitude. दूसरा क्या है? Amplitude और
Frequency.
phase. And third is
Yes, sir,
frequency.
phase.
Yeah. Third is
Frequency.
frequency. Third is frequency. So how to determine its frequency? Frequency means that in 1 second, how many signals or how many baud are being generated. Means that ये जो time period मैंने बताया एक signal तैयार होने के लिए, if this t equal to 1, that means what? एक second में एक ही signal generate हो रहा है. That case, its frequency will be 1 hertz. Yes or no?
Yes, sir.
Okay. Now I told you one thing that in our AC current that we are being supplied with 220 voltages by the APDCL. So what is the frequency of that current? आप लोगों को याद है मैंने बताया था कितना था वो करंट फ्रीक्वेंसी
सर क्या पूछा रिपीट कीजिए सर
मैंने
सुनाई
बोल
नहीं
रहा
दिया
हूँ हाँ तुम्हारा जो इलेक्ट्रिसिटी करंट आ रहा है थ्रू एपीडीसीएल
यस सर
so how much frequency is being generated what is the frequency of that current
तो 50
सर
हर्ट्ज
50 हर्ट्ज था
50 hertz so what do you mean by that 50
Yes,
hertz
सर एक सेकंड में 50 टाइम जो सिग्नल मतलब सर जा रहा है एक सेकंड में
means that in 1 second 50 signals are being generated
कमिंग यस
coming
सर
समझ गया that means within one this is the time period t na but within one total 50 signals will be generated so मान लो this is t equal to 1 right this is my t equal to 1 now within one if I consider this t equal to 1 इसमें क्या मुझे समझ में आ रहा है मुझे ये समझ में आ रहा है कि एक सेकंड में एक ही सिग्नल जनरेट हो रहा है but if I consider another signal within this time period t only ऐसे अब बताओ इसमें कितना सिग्नल जनरेट हो रहा है एक सेकंड में ये तो t equal to 1 ना
7 सर
सर 6.5
1 2 3 4 5 6 7 एक अब मान लो यहाँ तक कर दिया मैंने 7 तो यहाँ पे ये 7 है तो इसका
यस
फ्रीक्वेंसी
सर
1 हर्ट्ज इसका फ्रीक्वेंसी 1 अब समझ में आया
यस सर
so which one is high frequency signal then
the second one
हाई फ्रीक्वेंसी सर सेकंड वन
second one this one is low frequency signal
yes sir
अभी क्लियर हो गया एनालॉग सिग्नल which is featured or which is characterized by its frequency phase and amplitude okay now coming back to bpsk qpsk and ask psk and fsk sorry okay
FSK
now in case of ask amplitude shifting they are telling that you have a digital signal this is your time period suppose the digital signal is 1 0 1 1 0 0 1 okay now how it should be represented it should be represented like this if I consider plus 5 voltage as 1 and minus 5 voltage as 0 ऐसे ही represent होगा ना am I correct
yes sir
हाँ
यस
यहाँ पे समझ में नहीं आएगा please
Yes, sir.
stop me okay now the rule is that to convert a digital signal to an analog signal with amplitude shifting is that I will consider one carrier frequency. Carrier frequency is a high frequency which will carry the signal, carry the digital signal, one high frequency signal. Okay. Now I will change the amplitude of the carrier signal. This is my carrier signal. I will change the amplitude of the carrier signal with respect to the change of the digital signal. Means that if in the digital signal it is 1, that means plus 5 voltage, that case I will pass the amplitude as it is. If it is 0 or minus 5 voltage, that case I will stop passing the amplitude. Means that मैं गेट रख दूंगा उसमें सिग्नल आ रहा है गेट से whenever I will find out the digital signal is 1 I will pass the signal as it is. When the digital signal is 0, I will stop passing the signal. That is why it is called on-off keying. When digital bits 1 will come, it will on the signal. When the digital bit 0 will come, it will off the signal. इसका मतलब क्या हो गया? If I convert the same concept over here, when one is coming over here, na? So whatever be the signal, the same signal I will copy over here. A signal को मैंने copy किया. Whenever 0 is coming, I will stop passing the signal. उसका voltage को मैंने stop कर दूंगा. Next, whenever 1 is coming, I will let the signal to pass. Next 1 is coming, I will let the signal to pass. When 0 will come, अभी क्या करेंगे इसमें?
Stop.
Stop passing
sir.
the signal. I will stop passing the
Yes, sir.
signal. Okay, and when 1 will come, again I will let the signal to pass. Means तुम्हारा एनालॉग सिग्नल ही जा रहा है. एनालॉग सिग्नल में एक बार क्या हो रहा है, पूरा एक्चुअल सिग्नल जा रहा है, नेक्स्ट टाइम इट इज 0 वोल्टेज हो जा रहा है, एम्पलीट्यूड इज 0. नेक्स्ट टाइम एक्चुअल सिग्नल जा रहा है, देन 0, देन एक्चुअल सिग्नल. तो तुम्हारे पास instead of digital signal, analog signal is coming. Now from the analog signal, you can identify that whether it is digital bit 0 is whether it is carrying digital bit 0 or whether it is carrying digital bits 1. Whenever the actual signal is coming, I can say that the digital bits 1. Whenever 0 voltage is coming, I can say that it is digital bit 0. And whenever actual signal is coming, I will say that it is digital bits 1. Whenever 0 voltage is coming, I will say that it is digital bit 0. ये एक easy procedure हो गया ना? The receiver side,
Yes, sir.
I am taking analog signal, but from that analog signal, I can identify the digital bits. Is this clear?
Yes, sir.
Crisp and clear?
Yes, sir.
Okay. So this is called amplitude shift keying. Means that I am changing my amplitude to represent my digital bits. I am changing the amplitude of the analog signal to represent my digital bits. That is why sometimes this keying is called on-off keying. Means एक switch रख दो. Whenever digital bits 1 is coming, I will pass the signal. Whenever digital bits 0 is coming, I will stop the signal. That is the basic principle. Okay. Now come to frequency shift keying. So basic principle of this shift keying is that I will change the amplitude in case of amplitude shift keying. I will change the frequency in case of frequency shift keying. I will change the phase in case of phase shift keying to represent my digital bits in the analog signal. That is my main motto. Now, in case of amplitude shift keying, we are considering actual voltage and 0 voltage to representing 1 and 0. Now, what to do with the frequency? Because I need to take to represent 1 and 0, I need to take 2 types of frequency over here. क्योंकि मुझे frequency को change करना है. So for that, what we will do that we will take 2 kinds of frequency. In case of frequency shifting, we will take 2 kinds of frequency. मेरा digital bits क्या था याद है आप लोगों को? Can you repeat? Same digital bits लेके करते हैं तो आप लोगों को समझ में
Sir, 1 0.
एक मिनट. 1
1 0 1 1
1 0 1 1
1 1
and
0 0 1.
0 0 1. Correct? 1 sorry. Okay. 1 0 1 1 0 0 1. This is plus 5 voltage. This is minus 5 voltage. Okay. Now instead of 1 frequency, I will take 2 frequency. 1 frequency will be high frequency, low frequency, low carrier frequency. Both are carrier frequency, and its frequency is F1. Another I am taking high frequency. F2. Now what I will do that when digital bits 1 will come, I will pass the low frequency. Whenever digital bits 0 will come, I will pass the high frequency. Now at 1 should be represented by high or low, that will be dependent by you only. Now आप decide करो 1 को तुम low frequency से represent करोगे या हाई फ्रीक्वेंसी से रिप्रेजेंट करोगे? आई विल डू अकॉर्डिंग टू दैट.
1 high, 0 low, sir.
1 high, 0 low. Okay, fine. Now, yeah, this is so your modulated signal will be like this. Modulated signal will be like this. As one is passing, it should be high. Now, when 0 is passing, it should be low. Again, 1 is passing, it should be high. And again, 0 is passing, it should be low. Again, 1 is passing, it should be high. Now, at the receiver end, whenever I find out that for one time period, the high frequency is coming and another time period, low frequency is coming, what should I understand? The high frequency is my digital bits 1 and the low frequency is my digital bits 0. आया समझ में?
Yes, sir.
Yes, sir.
Easy technique है
Yes,
ना?
sir.
Easy technique है ना?
Yes, sir.
Okay. Now coming to phase shifting. Now in case of phase shifting, let us take the digital bits again. What is my digital bits?
So 1 0 1 1 0 0
एक मिनट.
सर
हाँ बोलो
सर
बोलो.
सर मेरा पहले वाला का डायग्राम थोड़ा रह गया सर.
कौन सा? Which one?
उससे पहले वाला से
ओ डायग्राम तो अभी तो ये तो डिलीट हो गया. एक काम करते हैं, आई विल शेयर यू द वीडियो देन. मैं
Okay,
वीडियो
sir.
शेयर कर दूंगा. हाँ अभी जो डायग्राम
Yes, sir.
ड्रॉ करेंगे ना, डू वन थिंग, इसका स्क्रीनशॉट ले लो. ओके. नहीं तो
Yes,
मैं
sir.
काम करूंगा नेक्स्ट टाइम से. मैं ये पावर पॉइंट में आई विल नॉट शो यू द बोर्ड फ्रॉम द पावर पॉइंट. आई विल शो यू फ्रॉम समवेयर so that I can store it as a PDF also for your lecture notes. ठीक है, चिंता मत करो, वो मिल
Yes,
जाएगा.
sir. Okay.
So it is 1 0 1 1. क्या था इसके बाद? So it is 1
So
0
0 0
1 1 then 0 0 ना? 0 0 then
Yes,
1.
sir.
Okay.
0 0 1
0 0 1.
Yes,
Okay, अभी
sir.
ये बंद हो सकता है. If it gets shut down क्योंकि 40 minutes हो गया, then you please rejoin. Now, in such case, in this case, what I will do that I will take one carrier frequency again in case of phase shifting. So this is phase shifting. So this is my carrier signal. Now what I will do in case of phase shifting, that whenever 1 is coming, I will take the actual signal, and whenever 0 is coming, I will take 180 degree out of phase of that particular signal. What do you mean by 180 degree out of phase? Means that इस जगह पे, इस पॉइंट में मेरा अगर टेंजेंट ड्रॉ करेंगे, उसका फेज एंगल कितना है, आई विल डिटरमाइन. सपोज यहाँ पे मेरा फेज एंगल है 0 डिग्री. तो इसके साथ मेरा ये तो फेज एंगल 0 डिग्री होगा ना, एक खत्म हो गया. Means that this is 0, this is 90, this is 270, sorry, this is 180, this is 270, this is 360. मैंने बताया था. तो 360 डिग्री means what? अगर इसको क्या करेंगे? It is 4 into 90 plus 0. That means sine 4 into 90 plus 0 means what? It is sine 0 ही होता है. So it is starting from 0 degree again. तो ये 0 डिग्री के साथ हम लोग क्या करेंगे? 180 डिग्री ऐड कर देंगे because it is out of phase. Means 1 will be represented by the actual phase of the signal and 0 will be represented by the out of phase of whatever phase angle was there at that point. Got my point? ये अगर 0 डिग्री है तो उसका 180 डिग्री out of phase होगा. So now it is very difficult for you to visualize what is 180 degree out of phase. So better I am giving you one tip that क्या करना है? जो तुम्हारा यहाँ पे सिग्नल आ रहा है उसका सिर्फ एक मिरर सिमेट्री बना दो। मीन्स वो सिग्नल को तुम आईने के सामने खड़ा करोगे तो उसका एक मिरर सिमेट्री जनरेट होगा। तो वो मिरर सिमेट्री देखने में कैसा होगा, लाइक दिस ना, आईना का सामने। यस और नो, यू टेल मी।
यस सर।
तो ये
Yes,
मिरर
sir.
सिमेट्री होगा इसका 180 डिग्री। इसका मिरर सिमेट्री क्या होगा, ऐसा आएगा ना, उल्टा तरफ से। इसका मिरर सिमेट्री क्या होगा, इसका मिरर सिमेट्री लाइक दिस। सो gist, cutting long story short, that if 1 is coming, I will take the actual signal. If 0 is coming, I will take the 180 degree out of phase of the signal. उसका जो वैल्यू आता है वही हम लोग उसमें रिप्रेजेंट करेंगे। और तुम लोग को ड्रॉ करने के लिए what you have to do, you have to draw the mirror symmetry of that actual signal. That will give you the two-way phase shifting. इसमें दो फेज का हम लोग चेंज कर रहे हैं ना, एक है आपका actual signal, another is out of phase signal. That is why it is called 2 Bpsk, binary phase shifting, Bpsk or binary phase shifting, because we are taking two binary phase angle for this shifting. समझ में आया?
Yes, sir.
Now this
Hello,
phase
sir.
shifting, binary phase has, समझ में आया कि नहीं आया? Yes बोला या no बोला?
Hello, sir.
हाँ
सर एक क्वेश्चन है सर।
हाँ बोलो बोलो।
सर ये आपने बोला था ये जो फेस शिफ्टिंग का, तो सर उसमें वो शेप सर लेफ्ट से राइट जाएगा या टॉप से बॉटम आएगा सर?
टॉप से बॉटम मैंने समझा नहीं। तुम सिर्फ एक काम करो।
नहीं मतलब सर वो सर लेफ्ट सर सिग्नल का लेफ्ट वाला जो पार्ट है वो राइट में मतलब मिरर में ऐसा दिखेगा या टॉप टॉप
नहीं, मिरर में
बॉटम
तुम
का
किसका
दिखेगा?
देखोगे? तुम तो ये मान लो ये मिरर है तुम्हारा, ये मिरर आ गया हाँ, इसका ही सिमेट्री यहाँ पे देखोगे, इसका सिमेट्री यहाँ
हाँ
पे
सर।
देखोगे, वही मैं बता रहा हूँ।
यस सर, अंडरस्टूड।
समझ गया? जस्ट मिरर को ड्रॉ कर दो और कुछ नहीं करना है तुमको।
ओके सर।
हाँ, इट विल मेक योर जॉब मच
सर
मोर।
मतलब सिग्नल के एंड में एक मिरर ड्रॉ करने से हो जाएगा सर?
हाँ हाँ हाँ, सिग्नल का एंड में, सिग्नल जिस जगह पे आके यहाँ पे रुक रहा है उसका मिरर सिमेट्री ड्रॉ
हाँ
कर दो।
सर।
पर ये लेकिन
Okay.
सिर्फ बाइनरी फेज शिफ्टिंग के लिए हो पाएगा, बट बाइनरी फेज शिफ्टिंग छोड़ के और भी बहुत सारा फेज शिफ्टिंग है, जैसे क्वाड्रेचर फेज शिफ्टिंग। क्वाड्रेचर फेज शिफ्टिंग में क्या होगा, 4 फेज एंगल यूज कर किया जाएगा। मीन्स दैट एक होगा मान लो 0 डिग्री फेज, एक होगा एक होगा तुम्हारा 45 डिग्री मान लो फेज एंगल, दूसरा होगा 45 प्लस उसका 90, कितना होता है 45 प्लस 90, 135 डिग्री फेज एंगल।
135।
another will be 135 plus 90, कितना होगा
225।
225। now another is 225 plus 90, कितना होगा
315।
315।
315। okay, and another will be 315 plus 90, कितना होगा
405।
405। 405 तो दिखाएगा नहीं क्योंकि ये 360 डिग्री से ऊपर आ गया, तो क्या होगा
हाँ सर।
405 माइनस 360, कितना होगा
360। यस
45।
45।
45 होगा, वही 45 से तो हम लोगों ने स्टार्ट किया। तो एक होगा 45 डिग्री, एक होगा 135 डिग्री, एक होगा 1225 डिग्री, एक होगा 315 डिग्री। तो ये होगा 4 क्वाड्रेचर फेज शिफ्टिंग के लिए। मतलब इफ आई वांट टू रिप्रेजेंट योर सिग्नल इनटू 4 फेजेस, 4 फेज एंगल्स। तो अभी 4 फेज एंगल में क्यों करना है, बिकॉज यू हैव ओनली 2 बिट्स, ओनली 0 और 1। यस और नो? उसके लिए तो 4 फेज एंगल नहीं चाहिए, 2 फेज एंगल से ही हो जाएगा।
यस सर।
आप लोगों को मैंने एक चीज दिखाया था, याद है? कभी कभी एक एक सिग्नल 2 बिट्स को कैरी करते हैं, जब तुम्हारा बिट रेट बॉड रेट से ज्यादा हो जाता है। नहीं दिखाया, याद नहीं आ रहा है? अच्छा
Oh,
भूल
sir.
तो भूल जाओ, it will make you complex, more complex. एक चीज याद रखना, suppose right now we are carrying one digital signal is carrying 1 bits, right? एक digital signal 1 bit को carry कर रहा है, so this one 0, this one 1. Whenever it may happens that one digital signal is carrying 2 bits, कैसे करेंगे? This is -5, this is +5. -5 is carrying 0 0, -2.5 is carrying 0 1, +2.5 is carrying 1 0, and +5 is carrying 1 1. Why they are doing this? So if I want to speed up the process, मेरा तो सिग्नल एक ही जा रहा है, एक ही सिग्नल में अगर 2 बिट्स ट्रांसफर कर पाएंगे, that case my speed will be higher, speed will be double,